Hey guys, gonna do just a real quick demo here for you on scientific notation. Excuse my whiteboard, I did steal it from my daughter. I didn't have a bigger one on hand, so that's what we're gonna use for now. So we talked a little bit about it in class, but I wanted to give you a visual that you can see a little bit better here. So if I have a large number, say I have 22,500,000. So the first thing, you need a number between 1 and 10. So you have to figure out where you're going to put that decimal. So you're not going to put it here because that would give you 0.25. So we are going to put the decimal here. So you're going to have 2.5. Because if we put it anywhere else, it's larger than 10. So we have 2.5. The next thing you're going to do, multiply it by 10. Automatically put that down. Now you have to count to see what power of 10 you were going to. So the decimal is here. You were going to say 1, 2, 3, 4, 5, 6. So it's going to be 10 to the 6th power. So that's the same as saying times 10 times 10 times 10 times 10 times 10 times 10. That's why it's to the 6th power. Each one gives you that place bigger. So that is going in that direction if it's a positive number. So a large positive number, it is going to be a positive power. So if we want to go the other way, so say we have a really small number now. Same thing first. Find out where you're going to put that decimal that is a number between 1 and 10. So in this case, our number between 1 and 10 is going to be 5. So we are going to have 5.31 times your 10. Now it is going smaller instead of larger. So we have a very small number. We automatically know it's going to be to a negative power. Now you count. Decimal, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's to the 9th power. And that's the same thing as we said before. It's just making it smaller times 10, 9 times. So 10, 10, 10, 10, 10, 10, 10, 10, and 10. Same thing. But each time it's getting smaller and smaller. So it would actually be, if you want to go full math, we would actually say it's divided by 10 that many times. Because that would be 1 over 10. But I'm not going to get into that detail of it. Just you need to know if it's negative, it's for the decimals. Positive is for those large numbers with a whole lot of zeros after it. Now if you wanted to go the other direction, now you have a number written in scientific notation. So I'm going to go back here. So we have, maybe we have 4.378 times 10 to the 5th power. The first thing you do is write your numbers out without the decimal. 4378. We know that our decimal point was originally here. So mark where it was, because that's where you're going to start counting from. It is a positive, so it is going to go to the right 5 spots. So we started here. So we are going to say 1, 2, 3, 4. So we're going to fill in a 0. 5, fill in a 0. So if we rewrite that, your number is 437800. Add your comma. If we're starting the other way, now I'm going to keep that there because I'm going to do almost the same number. We're going to say 4.378 times 10 to the negative 5th. It is easier if you start writing the number further to the right side of your paper if it is negative, because the zeros are going to the left, not the right. So I'm going to say 4378. Again, going to mark where that decimal was, because that's your starting point. It is 5, so we're going to say, starting here, 1. We're going to go 2, fill in your 0, 3, 4, 5. Add your decimal, add your starting 0. So your answer there is your 0.00004378. So that takes you setting it up in scientific notation and taking it out, whether it is a number larger than 1 or smaller than 1.